This is on the topic Pythagorean identity on Study Island. Let's get started. One thing that you have to remember to do the problems that they're asking you to do for this is the following. Imagine you've got the unit circle here on a coordinate plane. Obviously, the center of the coordinate plane, that's point 0, 0, that's the origin. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4, as always. Well, if we draw an angle, a central angle for this circle, let's go with the origin, and it intersects that arc somewhere, like that. If we call this angle theta, the angle created between those two lines, if we call that angle theta, then sine of theta will be a positive value, and so will the cosine of theta. They will both be positive values if theta is in quadrant 1. But if I had drawn that angle in a different quadrant, let's say quadrant 2 over here, and let's say theta was this angle from there to there. In this case, theta is in quadrant 2, and the sine of theta will still be positive, but the cosine of theta will be negative. If it's in quadrant 3, the sine of theta will be negative, and so will the cosine of theta. And if it's quadrant 4, the sine of theta will be negative, and the cosine of theta will be positive. You have to remember those combinations. You'll notice that the sine of theta follows the same rules as the y-coordinate would. If you were looking for an xy coordinate, everything above the x-axis is positive for the y-coordinate. Everything below the x-axis is negative for the y-coordinate. The same rules apply for the sine of theta. Similarly, cosine of theta follows the same rules as the x-coordinate, where everything to the right of the y-axis is positive and everything to the left of the y-axis is negative. So you have to remember sine and cosine, what's positive and what's negative in what quadrant. Again, sine of theta follows the rules for y, cosine of theta follows the rules for x. So that's one set of things that you have to remember to do these problems. The next thing you have to remember are the Pythagorean identities. These are written down right here in the lesson. You should have this tab open. If you don't know where these came from, go to the second tab, watch the Khan Academy video right here in this tab. It'll explain pretty clearly where these come from. And if you are not sure, after you watch that video, let me know and I can explain it a little better. But here's the main one. The sine of theta squared, I know it looks like it says sine squared theta, but it's the sine of theta squared plus the cosine of theta squared is equal to 1. Again, I don't know why it's written that way, but if somebody writes the sine of theta squared like that, it's the exact same thing as saying the sine of theta squared. Those two things mean the exact same thing. It's just the notation that we use in this particular case, so don't let that trip you up. But if you have the sine of theta squared plus the cosine of theta squared, that is always equal to 1. We're going to use that a lot to do these problems. Furthermore, we could develop these equations by using the fact that the sine of theta divided by the cosine of theta is always equal to the tangent of theta. The sine of an angle divided by the cosine of an angle is equal to the tangent of that angle. Again, watch that video from Khan Academy in the second tab in the lesson if you need help understanding why. This will give us some interesting definitions, and it will eventually lead to these two equations. So we use this equation if we have the tangent or cosine and we're looking for the other, and we use this equation if we have the sine or tangent and we're looking for the other. We use this one if we have the sine or the cosine and we're looking for the other. So now that we've got that figured out, we can jump right into these problems. The very first problem says, given the following, use the Pythagorean identity to find all possible values for the tangent of theta. It gives us the sine of theta. So again, if we go back, we use the equation that has sine and tangent because we were given sine and we're looking for tangent. The cosine of theta isn't particularly important in this problem. So we're going to use this equation, 1 plus 1 over the tangent of theta squared equals 1 over the sine of theta squared. We're going to use that to solve this problem. Again, it gave us gave us sine of theta. We're looking for tangent of theta. So go to your lesson and use the equation that has sine of theta, and tangent of theta in it. So let's go ahead and do that problem. First, I'm going to go ahead and write down that equation so I don't have to keep flipping back and forth. You will memorize it eventually when you use it enough, but I would write it down if I were you over and over again. Each time when you write it down, it'll help stick it to memory. So 1 plus 1 over the tangent of theta squared is equal to 1 over the sine of theta squared. And now let's go ahead and plug in what we know. We know the sine of theta. So 1 plus 1 over the tangent of theta squared is equal to 1 over. Now, I don't know the sine of theta squared yet. I just know the sine of theta. So I need the sine of theta, which is this whole thing, squared. So I'm going to write the sine of theta, which is 3 times the square root of 17 over 17. But I need to square this whole thing to get the sine of theta squared. So now I have to multiply this out and figure out what that is. Here we go. 1 plus 1 over the tangent of theta squared is equal to, what is this whole mess? Well, let's just do it one step at a time. 1 over, all right, what is this fraction squared? It's this fraction times itself. Well, that's going to be 3 root 17 over 17 times 3 root 17 over 17. That's what that'll equal. Well, we're going to end up doing 3 times root of 17 times 3 times root of 17. So let's just do 3 times 3 first, which is 9. And then I'll have the root of 17 times the root of 17, which would be 17. So it'd be 9 times 17 over 17 times 17. Now I'm going to write those individually now because I'm going to see the 17s cancel out, and I'll get 9 17ths. So the sine of theta squared is 9 17ths, because the sine of theta is 3 times the square root of 17 over 17, and 3 times the square root of 17 over 17 times itself makes 3 times 3, which is 9, root of 17 times root of 17, which is 17, and 17 times 17, which is 17 times 17. Then these 17s cancel out, and we have just the 9 over 17 left. So here's our new equation. 1 plus 1 over the tangent of theta squared equals 1 over the sine of theta squared, which happens to be 9 17ths. Now I'm doing 1 divided by a fraction, and 1 divided, anytime you divide by a fraction, you multiply by the reciprocal. So I'm going to do 1 times 17 ninths, which is clearly just 17 ninths. 1 times anything is itself. So our new equation becomes 1 plus 1 over the tangent of theta squared equals 17 ninths. Now I'm trying to solve for my tangent of theta squared, so what I'm going to do next is I'm going to go ahead and subtract 1 from both sides. Minus 1. Over here I'm going to subtract it in the form of 9 ninths. So minus 1 minus 9 ninths, same thing. I get 1 over the tangent of theta squared equals 17 ninths minus 9 ninths is 8 ninths. You should know that anytime you have one fraction equaling another fraction, that their reciprocals are equal as well. So 1 divided by the tangent of theta squared is the tangent of theta squared divided by 1, which is redundant to write. So if I flip this over, I just get the tangent of theta squared. If I flip this over, take the reciprocal of that, I get 9/8. So now all I have to do to solve for the tangent of theta is take the square root of both sides. So the square root of the tangent of theta squared is just the tangent of theta. Again, I'm just taking the square root of this, and of course that means I have to take the square root of the other side as well. And when you take the square root of something in an equation like this, you have to take the positive or negative version of it. Do not forget that. If you're not sure why, ask me about complex numbers and things like that, and we will go about taking the square root of radicals. So then you have the tangent of theta is the square root of 9 divided by the square root of 8. Now the square root of 9 is simply 3, so this is plus or minus 3 divided by the square root of 8. But I'm going to write the square root of 8 as the square root of 4 times the square root of 2. Because 8 divides by 4, 4 is a perfect square, I can rewrite the square root of 4 as simply 2. So now that becomes the tangent of theta is equal to positive or negative 3 divided by 2 times the square root of 2. Now, we think we're done, but we're not allowed to have a radical in the denominator. We're not allowed to have a square root symbol in our denominator. So I'm going to multiply this by 1, but in the form of the square root of 2 over the square root of 2. Multiplying something by 1 doesn't change it. The square root of 2 over the square root of 2 is equal to 1. And that is going to make me get rid of the radical in the denominator because I'm going to do the square root of 2 times the square root of 2, which is 4. So now it becomes tangent, or excuse me, square root of 2 times square root of 2 is the square root of 4. And the square root of 4 is back to 2. The square root of 2 times square root of 2 is 2. So the tangent of theta is equal to plus or minus 3 times square root of 2 divided by 2 times 2. Again, square root of 2 times square root of 2 is 2. And we have 2 times that. So it's 2 times 2, which is 4. So I have positive or negative 3 root 2 over 4. So I'm going to look at my options here. I don't know what quadrant all these things are in, so I couldn't tell if cosine or any of those things are positive or negative. So we're just going to stick with both answers. It's asking for all possibilities. So I have negative 3 times the square root of 2 over 4 and positive 3 times the square root of 2 over 4. All right, next question. Number 2, given the following, use a Pythagorean identity to find the cosine of theta if theta is in quadrant 4. And it's given us the tangent of theta. So again, if we go and look at our lesson, the identity that we can use that uses tangent and cosine, the two things that we're interested in, is right here. The tangent of theta squared plus 1 is equal to 1 divided by the cosine of theta squared. So let's go ahead and again, writing it down is a good way to remember it. You'll remember them eventually. The tangent of theta squared plus 1 is equal to 1 divided by the cosine of theta squared. And if you'd like to know where these identities come from, again, watch that Khan Academy video. And if you still don't get it, let me know and I'll walk you through it if you're interested. But to do these problems, all you really have to do is remember it. But I'm more than happy to explain where they came from if you're curious. So here we go. The tangent of theta is negative 5/12. So the tangent of theta squared would be negative 5/12 squared. So I have the tangent of theta squared plus 1 is equal to 1 over the cosine of theta squared. So negative 5/12 times itself would be 5 times 5, which is 25. And 12 times 12, which is 144. And a negative times a negative is positive, so I'm going to stick with that for now. Plus 1, I'm going to write that as plus 144 over 144 equals 1 over the cosine of theta squared. So I'll go ahead and add those together. 144 plus 25 is 169. So you get 169 divided by 144 is equal to 1 over cosine of theta squared. Again, one fraction equals another, then their reciprocals are equal to each other. So you can simply take the reciprocal of each side here to solve for the cosine of theta squared. So the cosine of theta squared is 144 over 169. Again, if you flip over the cosine of theta squared, you just get 1 over the cosine of theta squared. If you flip that over, you just get the cosine of theta squared over 1. And there's no need writing over 1 for that. And now we just simply take the square root of both sides. Again, when you take the square root, you need a positive or negative version of it. So over here, we have the square root of 144, which is 12, and the square root of 169, which is 13. So you have the positive or negative version of that is equal to the cosine of theta. Now, that's our answer, but you see we have 12/13 and negative 13ths. We have to remember that the cosine of theta, if theta is in quadrant 4. So what are the rules for the cosine of theta? Remember, the cosine of theta follows the same rules as the x-coordinates would. In quadrant 4, the cosine of theta is positive. So while our math came out saying that we could have a positive or negative answer, if theta is in quadrant 4, it's going to be positive. So we have positive 12 over 13. So we just have 12/13 in this problem. All right, another one where we have tangent and sine, and it gives us a quadrant. So here we go. Use the Pythagorean identity to find the tangent of theta if theta is in quadrant 1. The sine of theta is equal to 5 times the root of 31 over 31. So again, you're using the identity that has tangent and sine, which is the first one we did from problem number 1, this one. So we're going to go ahead and write that down again. So you've got 1 plus 1 over the tangent of theta squared is equal to 1 over the sine of theta squared. And now we just fill in our information. We know the sine of theta is 5 root 31 over 31. So 1 plus 1 over the tangent theta squared is equal to 1 over that whole thing squared. So we've got 5 root 31 over 31 squared. So again, this is if the sine of theta in the problem is 5 root 31 over 31, like it says in the problem right there. So we just plugged it in for the sine of theta squared. We have the sine of theta squared now. So let's go ahead and simplify that. 5 times, if we're going to square this, we have 5 root 31 over 31 times itself, 5 root 31 over 31. And we just did a problem just like this. We did 5 times 5, and we did root of 31 times root of 31, except for it was, in this case, 3 and 17, right? So we ended up doing 3 times 3, which was 9, and the root of 17 times root of 17 was just 17, and it ended up canceling itself out, right? Well, it's going to be the same pattern here. We have 5 times 5, which is 25. The root of 31 times the root of 31 is 31. So on the top, we have those things multiplied together. 5 times 5, 25, times the root of 31 times the root of 31, so times 31. And on the bottom, we have 31 times 31. And the 31s cancel out. So if you see something written in this format, you're going to square it. You can pick up that pattern pretty quickly, and you don't have to write this out every single time. So you just get 25 over 31 there. So here we go. 1 plus 1 over tangent of theta squared equals, and I'm also going to take another shortcut right here. If this squared is 25 over 31, and we're doing 1 divided by that, okay, so I'll just write it out so you're not confused. Just as before, if we're dividing by a fraction, we are multiplying by the reciprocal, so we are doing 1 times 31 25ths. Again, we're dividing by 25 31sts, so we're going to multiply by 31 25ths. 1 times 31 25ths is just 31 25ths. So we have a new equation, 1 plus 1 over tangent of theta squared. And feel free to, if you see these patterns coming up ahead of time, I mean, right from here, you could jump to this next part fairly simply. It's going to be 31 over 25. Now we'll subtract 1 from both sides. So we get 1 over the tangent of theta squared. Again, I'm just subtracting this 1 right here. Of course, if I subtract 1 from the left side, if I subtract 1 from the right side, I'm subtracting 1 in the form of 25 25ths. So 31 25ths minus 1 is 31 minus 25, which is 6. So we get 6 25ths. And now we have one fraction equals another, so their reciprocals are equal to each other. So tangent of theta squared is equal to 25 sixths. And we take the square root of both sides, the square root of tangent theta squared, and the square root of that. It's the positive or negative version. You have the tangent of theta is equal to the square root of 25 is 5, divided by the square root of 6. But again, I'm not allowed to leave a radical in my denominator, so I will multiply both sides of that by the square root of 6. So again, I'm just multiplying this fraction times 1, so I'm not really changing its value. I'm just changing the way it looks. Root 5 over 6 times root 6 over 6, root 6 over root 6 equals 5 times the root of 6 over root 6 times root 6 is just 6. And all of this is the positive or negative version. So we have 5 root 6 over 6. 5 root 6 over 6 is our answer. But remember, everything's in quadrant 1, so everything's going to be positive at this point. So we've just got 5 root 6 over 6. Next one. Given the following, use a Pythagorean identity to find cosine theta if theta is in quadrant 1. So finally we got one that uses sine and cosine and doesn't involve tangent. So we get to use the original identity, which in this case was sine squared plus cosine, sine theta squared plus cosine theta squared is equal to 1. So the sine of theta squared plus the cosine of theta squared is equal to 1. So this is our identity we're going to use for this one because it gives us sine and asks us about cosine, so we don't need tangent. So let's go ahead and get started. The sine of theta is 12/13, so the sine of theta squared is 12/13 squared plus the cosine of theta squared is equal to 1. 12/13 squared is 144 over 169. Because 12 times 12 is 144, 13 times 13 is 169. So plus the cosine of theta squared is still equal to 1. Subtract from both sides. We're just doing our basic algebra at this point to isolate our cosine of theta squared. So I have the cosine of theta squared is equal to 1 is 169 over 169. So 169 minus 144 is 25. So I get 25 over 169. Now we take the square root of both sides. So the square root of the cosine of theta squared is just the cosine of theta. And that gives us the positive or negative version of this, the square root of both of those, which is 5 over 13. Again, what I just did was I took the square root of both sides. Square root of 25 is 5, square root of 169 is 13. And again, you always want the positive or negative version of it. So the cosine of theta is positive or negative 5/13. But again, it's in quadrant 1 where everything is positive. So I don't really want the negative version of it. I just want positive 5/13. If this is in a different quadrant, maybe it changes the sign. But right now, we're going to stick with the positive 5/13. Let's keep it going. Given the following, use a Pythagorean identity to find the cosine of theta if theta is in quadrant 4. Gives us sine again. So we're going to use the same one, sine of theta, cosine of theta, sine of theta squared plus cosine of theta squared. But we're going to use quadrant 4 instead. So again, sine of theta squared plus the cosine of theta squared is equal to 1. And sorry for the little right there. Okay, here we go. So the sine of theta is negative 2 root 5 over 5. So we have negative 2 root 5 over 5 squared plus the cosine of theta squared is equal to 1. So what is this monstrosity when we multiply it by itself? Well, the negative times the negative is a positive, so we don't have to worry about that. 2 times 2 is 4. Root 5 times root 5 is 5. And one of those 5s is going to cancel out with the bottom being 5 times 5, so it's just going to be over 5. Again, if you're not sure how that worked out, I'll extend it one more time for you. We have negative 2 root 5 over 5 times negative 2 root 5 over 5. We're doing this times itself, so we have this times itself. We're going to have negative times a negative, so it's a positive. And then 2 times the root of 5 times 2 times the root of 5. I'm just going to reverse the order. I'm going to do 2 times 2, which is 4. And the root of 5 times the root of 5 would be 5. So it'd be 4 times 5. And I could write 20, but that's a waste of time because on the very bottom, I'm doing 5 times 5. So I could have 20 over 25, or I could just see that they're both multiplying by 5, so those 5s cancel out, and I just have 4 over 5. So here we go. Now that I have that, I can subtract 4/5 from both sides. So I have the cosine of theta squared equals 1 minus 4/5, which is 5/5 minus 4/5, so 1/5. So now I take the square root of both of those sides, and I get the cosine of theta is equal to the square root of both of those. Now the square root of 1 is 1. So I'm going to get 1 over the square root of 5. Square root of 5 I can't write that way. But I will multiply both sides by the square root of 5 over the square root of 5. So I have the cosine of theta equals positive or negative. 1 times the square root of 5 is the square root of 5. The square root of 5 times the square root of 5 is just 5. So that's my answer. Positive or negative, root 5 over 5. But what quadrant are we in? Quadrant 4. So if we're trying to find the cosine of theta and we are in quadrant 4, is that positive or negative? Well, you got to remember back to the original thing I showed you, these rules. The cosine of theta follows the same rules that x does. So in quadrant 4, the cosine of theta is positive. So we're going to be looking for the positive version of the root 5 over 5. And that's right there. All right, we got another one. Given the following, use the Pythagorean identity to find the tangent of theta if theta is in quadrant 3. The cosine of theta is negative 2/3. So we're dealing with cosine and tangent again. Right here, that's this one, tangent and cosine. So let's go ahead and write the equation down once again. You've got tangent squared, tangent of theta squared, plus 1 equals 1 over the cosine of theta squared. So you've got your tangent and cosine equation right there for you. Plug in negative 2/3 for your cosine of theta. We're going to square that. So the tangent of theta squared plus 1 equals 1 over negative 2/3. That's the cosine of theta squared because we want the cosine of theta squared. So the tangent theta squared plus 1 equals 1 over 2 times 2 is 4, 3 times 3 is 9, so 4/9. Again, negative something negative is positive. So the tangent of theta squared plus 1 equals 1 divided by 4/9 is 9/4, because again, you're dividing by a fraction, so you're multiplying by the reciprocal. 1 times 9/4 is simply 9/4. Forget the 1 that I forgot to write. Now subtract 1 from both sides, and you get the tangent of theta squared is equal to 9/4 minus 4/4, which is 5/4. And finally, take the square root of both sides, and you get the tangent of theta is equal to the square root of 5 over the square root of 4, which is 2, but I want the positive or negative version. Now, in this case, you've got to remember the quadrant. It's quadrant 3. In quadrant 3, sine and cosine are both negative. Sine and cosine are both negative. And the sine of theta divided by the cosine of theta is the tangent of theta. So if we're going back to our problem, what is the tangent of theta? Is it positive or negative? Well, in quadrant 3, we have the sine of theta divided by the cosine of theta equals the tangent of theta. So the sine divided by the cosine is tangent. If the sine is negative and the cosine is negative, what's a negative divided by a negative? Positive. So the tangent would be positive in this case. So it's positive root 5 over 2. Now, if you want to add those rules back into your original circle, that might be a really good idea. So what's a positive divided by a positive? It's a positive. So that means the tangent of theta is going to be positive as well. But what's positive divided by a negative? A negative. So the tangent of theta in quadrant 2 would be negative. A negative divided by a negative is positive, so the tangent of theta here is going to be positive. And then over here, the tangent of theta is a negative divided by a positive, so the tangent of theta is negative. So you can refer back to that if you need to. Let's go ahead and do some more problems. Given the following, use a Pythagorean identity to find the cosine of theta if theta is in quadrant 4 and it gives you sine. So again, we're dealing with sine and cosine. So we have the sine of theta squared plus the cosine of theta squared is equal to 1. It gives us the sine of theta, so let's go ahead and plug that in. We've got negative 2 root 13 over 13 squared plus the cosine of theta squared equals 1. Multiply this by itself, we're going to get 2 times 2, which is 4, root 13 times root 13, which is just 13, and it's going to cancel out with one of the 13s. That's 13 times 13 on the bottom, so we'll just have 4 over 13, plus cosine of theta squared equals 1. Then subtract 4/13 from both sides. 1 is 13/13. 13/13 minus 4/13 is 9/13. So the cosine of theta squared is 9/13, which means that if I take the square root of both sides, I get cosine of theta is equal to the square root of 9, which is 3, divided by the square root of 13, which I just write as the square root of 13. Now I go ahead and multiply by root 13 over root 13, and I get that the cosine of theta is equal to positive or negative 3 root 13 over 13. And then I check my quadrant 4. In quadrant 4, my cosine is what? Remember, cosine follows the same rules as the x value. So in quadrant 4, cosine is positive. So we've got 3 root 13 over 13. I feel like that's pretty much the gist of it. If you have any more questions, feel free to let me know. I can do more examples, or if you get a particular problem in here that is not like the ones I've done, let me know and I can help you out.